Alright, our goal with this video is to review adding and subtracting integers and to understand why we're doing what we're doing. Okay, so first, quick review of integers. Integers are any numbers with no fractional part. So integers are not numbers with decimals, and they are not numbers with fraction parts. 3.25 is not an integer because it has a fractional part, less than 1. All right. Negative 2 1/4 is not an integer because it has that fractional part. So integers include 0, positive whole numbers, and their negative opposites. The dots mean that they keep on going. So negative 4 is also an integer. Negative 5, negative 100, negative 1,000,000, those are integers. The dots over here mean they keep on going in a positive direction. 4, positive 4 is an integer. 758 is an integer. 1,052 is an integer. Okay, so 0, positive whole numbers, and their negative opposites are integers. We also need to talk about opposites. So I Googled opposite, and this is what it told me. I didn't even ask it for the math definition. But opposite is having a position on the other or further side of something. In math, something is 0. Okay? So 1's opposite is on the other or further side of 0. The opposite of 1 is negative 1. The opposite of negative 1 is positive 1. Let's go negative 5. Its opposite is on the other or further side of 0, an equal distance. So 5 and negative 5 are opposites. Okay, what happens when a positive and negative get together? Just a quick review, all right? If we're combining one positive with one negative, put a positive and a negative in a box. Open up the box a second later, what's in there? Absolutely nothing. Okay? Combining a positive and negative, one positive and negative make 0. All right. When you hear me talk about positive and negative numbers, I will always tie them back to money because that's how it makes sense to me. So positive amount means I have money. 16, positive 16, I have $16. Negative 16 would mean I owe someone $16. So whenever I see that negative, I think of it as money that I don't have. I owe it to someone. So as soon as I get money, I have to give them some money. All right. Now, the other big thing you need to know before we start actually adding integers is when I see plus, and when you see plus, I don't want you to think plus. I don't want you to think add. I want you to think and. Plus always, always, always means and. Okay? So in this first example, this looks like this. I have one positive and how many more positives? 3. Now I wouldn't walk around saying I have 1 and 3. I just say that altogether I have 4 positives. Next problem. What does this mean? It means I have 2 positives and I have 7 positives. But why would I say that? I would just say that I have 9 positives. All right? This can apply to things that aren't math as well. All right? I don't have 2 stars plus 3 stars. I have 2 stars and 3 stars. And why wouldn't I just say that I have 5 stars? Feel free to compliment my beautiful star drawing later. Okay, so now adding integers. This one means I have 4 positives and 2 positives, so I have 6 positives. All right, here we mix things up a little bit. We start throwing in negative integers. Here I have 4 positives and I have 2 negatives. Looks like an equal sign, doesn't it? All right, so if I would put my 4 positives and my 2 negatives in a box, all right, when I open the box, I'm going to see that these positive, or this positive and negative, have combined and made nothing, okay? And I will see that I'm also missing another positive and a negative, because every time we get one positive and negative together, they disappear. Okay, so then all that's left in my box are 2 positives. And if I look at that in money terms, it makes sense too. I have $4 and I owe $2. So when I pay back my debt, I pay back that $2, I still have $2 left. Okay? Last example. I owe 4 and I owe 2. Or 4 negatives and 2 negatives. Combine them in a box, 1, 2, 3, 4, and my 2. Close the box, open the box, and guess what? There aren't any positives to cancel with these negatives, so nothing gets to disappear. I have 6 negatives, and that makes sense. I owe $4 and I owe $2, so altogether I owe $6. Okay, I have a question for you. Could the world exist without subtraction? Could mathematicians who use math every single day, could they function without subtraction? Think about that for a second. Okay, now I would like you, in your head or on your calculator, but in some sort of way that you know you will get the right answer, I would like you to figure out the answer to those 2 problems. Huh, same answer. Coincidence? Maybe. All right, let's move on. On your calculator, or in your head, whichever way you know you'll get the correct answer. Figure out the answer to those 2. So pause, figure out the answer. There's what I got. Huh, coincidence again? I don't know, something's starting to smell a little fishy. All right, so next set of problems, you know the drill. Figure out the answer. Pause it while you do that. Here's what I got. That fish is smelling stronger and stronger, guys. All right, last problem. -2 minus -8, -2 plus 8. Punch them in. Behold. Same answer again. What is up with that? Okay, let's look at these first 2 problems up here, going across. The only thing different in these problems is one says subtract, one says adding the opposite. So if we didn't want to subtract, we could add the opposite and get the same answer. Next set of problems. Subtract, add the opposite. That's the only difference. Numbers are the same, but we still got the same answer. Subtract, here we wrote, adding the opposite of the next number. Same answer again, still works. And down here, we turn subtracting a negative into adding a positive. So, again, exact same answer. This column was all subtraction. This column was all adding. So far it looks to me like we don't need subtraction at all. We can just add. All right? So subtraction does not need to exist. Woohoo! I should hear shouts and cheers from wherever you're watching this video. Your math life just got so much easier. If you don't have to subtract anymore and you just have to learn addition, that's awesome. Okay? Subtracting is always the same as adding the opposite, always. You can always turn subtraction into adding the opposite of whatever comes next, and you'll get the same answer as if you would have subtracted. Okay, so why make things hard on ourselves? Let's just add. This year, we will just add. Okay, so change subtraction to addition. It always works. The first thing I'm going to do in these problems, these lovely, beautiful math problems, sorry I didn't give you more, is I'm going to look for subtraction. So first problem, is that subtraction? Yes, subtraction always comes after a number, so in that case, yes, it is subtraction. Let's move down the list. That looks like subtraction. It's the same symbol. Is it subtraction? No, because it does not come right after a number. It comes after another operation. So that is not subtraction. We don't have to change anything there. That's a good thing. All right, this one, is that subtraction? Yes, it comes right after the number -3. Woo. Okay, fix that. Now, my question, is this one also subtraction? Does it come right after a number? Nope. So it is not subtraction. All right. This problem over here, is that subtraction? No, it does not come directly after a number. Subtraction right here. Whoops. There we go. This one is subtraction. The other 2 are not because they don't come right next to a number or right after a number. Subtraction, the first one in front of the 2 is not subtraction because it does not come right after a number. All right, subtraction, subtraction. All right, so now we change it to adding because we know how to add. So subtraction is the same as adding the opposite. So I change my subtraction sign into adding. Okay. The opposite of what comes next. So the opposite of positive 4 is negative 4. This problem becomes 10 plus negative 4, or 10 positives and 4 negatives. All right, next problem. No subtraction, don't change anything. 22 positives and 6 negatives. All right, this problem down here. Change subtraction to adding. The opposite of what comes next. Opposite of positive 4 is negative 4. So negative, 3 negatives, and 4 negatives. Just combine them so we have 7 negatives. All right, over here, nothing to change. 7 negatives and 2 positives leaves me with 5 negatives altogether. This next problem, change subtraction to adding, and then take the opposite of whatever comes next. So the opposite of negative 3 is positive 3. So we get negative 2 plus positive 3. All right, next problem. Subtraction is the same as adding. The opposite of what comes next. The opposite of positive 3 is negative 3. So we have negative 2 plus negative 3. Next problem over here is negative 1. Take subtraction, turning it into adding. The opposite of 1 is negative 1. So negative 1 and negative 1. This problem, no subtraction, our job is easy, 2 negatives, and I have 24 more negatives. So if I owe 2 and I owe 24, I owe 26. And last problem, subtraction is the same as adding. The opposite of what comes next. So the opposite of negative 10 is positive 10. 44 negatives and 10 positives. All right? In your math book, notebook, please write down for tomorrow one question or comment you have that shows me you watched this video. So it can be a math problem in this video. Maybe you want to solve this problem right here. It can be a question you have. It can be a comment on something you saw in the video and you didn't know before. So just to review, we defined integers. We defined opposites. We practiced adding integers. We talked about the demise of subtraction and how we never need to use it again. And we practiced problems that involve both adding and subtracting integers.